Dr. Nestor, thank you very much for the invitation. I see it is already afternoon, so I'll try and be quick. If you cannot hear me clearly, then please tell me, but I am assuming that the sound is working and I will proceed. So I am indeed from South Africa, from the University of Pretoria. I'm also a member of the International Affairs Committee of the American Academy of Forensic Science. And I often wonder why we do not have more collaboration between the various groups of people, especially Europe and the Anglo-Saxon part of the world. And I hope it's not caused by the difference in our legal systems. The fact that in South Africa, like in the ex-British colonies, we use an adversarial legal system, and in Europe it tends to be a civil legal or codified legal procedure. And certainly forensics should not be affected by that. There is my disclaimer in it. And then I am actually on a crusade. In digital forensics, we try to be police officers. We try to be detectives. And if you read most of the science on digital forensics that's been published, you will see that we are trying to solve crimes. But that's actually the work of the police, of the detectives. That's not the work of the scientist. And what that means is we don't have a proper scientific basis for our work. We rather tend to be a very technology-oriented field. And in essence, what we do is we search for information. We try and find the information on a computer, on a network, in a database, in the cloud, and so on. And that, frankly, is not very scientific. Also, in the welcoming session this morning, I heard quite a couple of remarks about civil cases. And in digital forensics, we very often ignore civil cases when we just look at criminal cases. We want to find the criminal, the fraudster, or whoever committed the crime. And that needs to change. I am swimming stream up here. I am doing things differently from my colleagues. And I'm one of the few voices trying to go on this route. So any other experts who are listening to me will probably saying that I am doing things wrong. So what we have in the physical forensic field is that the forensic disciplines are defined by questions. In ballistics, the question is, was this round fired by that gun? The question is, was this, or what path did the bullet follow? With fingerprints, we want to identify the human who is associated with the fingerprints. Toxicology, we want to know what substance was involved, and so on. So there's a very clear question. And what we try and do in digital forensics, when we look at things like cloud forensics or database forensics, we are really looking at the tools that are being used. And in the physical world, that would be equivalent to talking about axe forensics, where axe is a tool, and whether that axe was used to chop wood or whether it was used to kill someone wouldn't matter, because it would focus on the tool. And the same for pen. You can kill someone with a pen, or you can write a note with a pen. Or in terms of contexts, we would look at house forensics and castle forensics, and hopefully that is obviously just silly. It is not the way that forensic science works, and we need to get back, or we need to get in line with other fields of forensic science. Now, what I want to do here is I want to look at questioned digital documents. So this is an extension of what people are doing in the field of digital rather in the field of questioned documents, or in the field of forensic document examination. And I want just to add the digital angle to that. In other words, I don't want to reinvent the wheel and say digital forensics is something totally new. Now, the moment that I say that, I have to assume that I am going to work with document examiners who know the field of document examination. At the previous event, I looked at documents that have been signed digitally. For today, I want to say what can be deduced from the internal document structure. So if you look at the inside of the document, and then I want to use the work of Inman and Rudin. And Inman and Rudin specified a set of principles or a set of questions, and they said that those are basically the questions that can be asked by forensic science. And I want to base this on a principle that I'm calling programmed execution, so that there is a scientific basis for it. A programmed execution is just a simple notion that a computer will follow a program to the letter. Now, if we know that the computer will follow that program, then we can predict and we can explain. And those are the hallmarks of science. And that is why I think it is a sound basis. I can spend hours talking about this, but I'm not going to do that. And just as a note, the execution of the program does depend on the inputs that are provided. So every time you run it, if you provide it with different inputs, then you will get somewhat different outputs. But what I'm thinking about here in terms of documents is if you're sending out accounts, then typically the account holder's details will change, but not the manner in which the document, the account, is produced. If we look at what Inman and Rudin say, then I just want to say I'm using them somewhat freely. So I'm looking at the concept that they focus on rather than the exact details that they provide. And what they do is they look at the processes of criminalistics. And those processes are really phrased slightly differently. They are the questions that can be asked by forensic science. Their point of departure is the visible matter. So if you have material and it divides, then based on that, you have a problem. So what we are seeing is that let me just double check. I hear pings. I hope it's not someone telling me that they cannot hear me. But the questions that are asked are then identification, and I'll go into that in a moment or two. It's also classification, which isn't really a process according to Inman and Rudin. There is individualization, which is something we cannot really do in digital forensics. There is association, where you associate parties with one another. And then there is reconstruction, where you reinvent something or redo something. Now, if we look at the specific questions, then identification is the question, what is it in general terms? And Inman and Rudin provides us with the example where they look at the alcohol level in blood. And they say, if you find alcohol and it's above the legal limit, then you don't have to search any further. You don't need the vintage of that alcohol. You've already proven your case. Now, the physical example is where you spray luminol to identify blood. In the digital case, we want to be able to say that this is an email or this is an entry in a database, and then look at the content of that email. So it's not particularly hard, it's not particularly technical, and the typical document that we will be dealing with, if it's an email or something, then that would be compatible in a sense with the programmed execution. Classification is the question, what is it? According to Inman and Rudin, it's things that come from the same origin. So physical examples could be something like paint on a car, where you can identify the paint. This comes from a Mercedes-Benz that was produced in 1990, but you don't know which specific one, or even ink from a pen. And this relates to the genotype and phenotype differences that we also saw in Dragan's examples, where he worked with the phenotype. And then the digital example would be the creation tool. I am not sure why I'm hearing the pings, so and I cannot see the comments right now. So if anyone is trying to communicate with me, I would appreciate it if some. So let's just go back there. So classification is if it's the same origin. And in the digital case, we look at the digital tool marks. There we have two PDF files. If you look at the inside of those PDF files, you will, just by looking at them, see that they look very, very different. And this is not related to the content. This is related to the tool that created them. So based on the tool, we can classify. Individualization is something that we can't really do, and there is a list of reasons why not. And I think given the time, I'm going to move on. Association typically happens when two objects come into contact with one another. It is basically Lucard's principle that is everybody is familiar with. In the digital world, where you edit something, the editor can leave marks on the object that is being edited. But given that those marks, they're not really about two objects. So when we want to begin to look at two objects, then there is an opportunity to think about divisible objects. An email with an attachment. The email and the attachment are associated, and they can be related to one another. And also email where you have the earlier conversation included. And then finally, in this list, reconstruction is the question, when something happened, what happened. In the physical world, it refers to a timeline of events. It may involve experimentation where you try and repeat parts of it. In the digital world, if you execute the program again, you can recreate the issue very simply without any problems. And so we really have a good tool here. We can reconstruct. Now, the document questions that we can be asking then in a broader context is, does the document look the way we expect it to look? How old is the document? What is the purpose of the document? For example, is it malware? Is it a virus or Trojan horse? We can look at the document internal consistency, and to some extent, we may be able to look at document origin. At the bottom of the screen, you will see that there are quite a couple of investigative leads, things that detectives can use and go further with. But that then I would suggest is beyond the scope of the document examiner. So summary, we need to collaborate. I, as a digital forensic scientist, cannot do this sort of work without talking to people who work in question documents. Question is, Inman and Rudin's list exhaustive in the digital context, or do we need to add more questions? And then by way of summary, those 5 processes, we can basically do what we set out to do using either the principle that I introduced, or for number 4, a new principle that I have to think about, divisible objects. And then clearly this work, this idea needs to be tested much, much wider And there are some other interesting things that we can do in future. Hopefully I've remained more or less within 15 minutes, and I assume that questions will follow later on in the session or whatever. So thank you very much for your attention. I appreciate the invitation.